In this last lesson in Chapter 3, we're going to look at another way to test for streakiness, which is to test for the number of streaks instead of the length of the streak. One problem with using the longest streak as our test statistic is that it doesn't work well for athletes or teams with many moderately long streaks. For example, if a team has 5 wins, 5 losses, 5 wins, 5 losses, and so on for the entire season, we would think that they're streaky even though their streaks are not very long. So sometimes we want to use a different test statistic, and in this case, it's going to be the number of streaks. But we need to spend a little bit more time considering what constitutes a streak. If we have sports with a short season, such as high school football, which only has 8 games, then 3 in a row would be considered a streak. But if we're looking at Major League Baseball, which has 162 games, 3 wins in a row or 3 losses in a row isn't really that significant. So, what constitutes a streak generally is the number of overall games that the team or the athlete has in a season, or the number of performances that they're attempting. Up until now, we've mentioned that 3 in a row is the minimum number that we need to constitute a streak. So we don't count 2 in a row as a streak. And as a general rule, we will say that if an athlete or a team has less than 50 attempts or games, then we will still consider 3 in a row to be a streak. So that would be something like high school football, for example, or even in the NFL, where they only have 16 games in their season. If a sport or an athlete, however, has between 50 and 100 performances or attempts or games, then we want our streaks to be a little bit longer. So then we're going to require that we have to have at least 4 in a row to be considered a streak. And if we have an athlete or a team that has more than 100 games or attempts, then we want our streaks to be even longer. So we would be looking for at least 5 in a row. So that would be the case for Major League Baseball. If they had 3 or 4 wins in a row, we would ignore those and we would only count 5 in a row or more as a streak. So we're going to look at, for example, the first 44 games of the NBA season. And at that point, the Houston Rockets, this was from 2015-16 season, had won 22 and lost 22. So they were exactly 50-50 for the season. The results of their first 44 games are listed there in order. So what we're going to do first is go through and underline all the streaks of 3 or more. And we're doing 3 or more because 44 games is less than 50. So anything 3 in a row would constitute a streak. So I noticed right at the beginning, they start off with a streak of 3 losses in a row. Then they have 4 wins in a row. So that would be another streak. And then they have 4 losses. Then we have 3 losses down here. There's 3 wins in a row. 3 more wins in a row. And we've got 4 losses in a row. And then they finish with a streak of 5 wins in a row. So their longest streak is only 5 in a row, which doesn't seem very significant. But in this case, we're testing for the number of streaks. And in this case, they ended up with 8 streaks during the first 44 games of their season. Now, even though the test statistic is going to be different, the hypotheses will still be written using the same format. So our null hypothesis is that the outcomes of the Rockets games are independent. Our alternative hypothesis is that the Rockets are a streaky team. Again, our test statistic is the number of streaks, so that's going to be 8. Now, the streaks applet that you've used in the past can be used for the number of streaks as well. And there are some instructions in your notes for how you're going to set that up differently. You still need to type the results of the 44 games into the box, and you're using S for success instead of W for wins, and F for failure instead of L for losses. You are going to have to make one other small adjustment. So this is what the applet looks like. Notice I've typed the results from the Rockets' first 44 games in that box. And I want to do 100 trials of this simulation. So we've got 100. But in this case, you're going to need to do a couple of different things. You are going to tell the applet what length of streak you want to count for. And in this case, we're using 3 as the length of the wins or losses in a row that will constitute a streak. And then there's this drop down here. And this is where you tell it which test statistic you're using. We're not doing longest streak anymore. We're doing number of streaks. And so if you change that drop down, it will say how many streaks are above length. And the length is the 3 that you put in up above. So we put in 100 shuffled responses. We're going to click the Add More Trials button, just like we always do. And this is the results that I came up with when I did it. I had the applet count the number of dots for me. So down at the bottom, I asked it to count the number of dots that are greater than, you have to change that from less than to greater than, and you put your test statistic in there, which is 8, because we had 8 streaks, and that was our test statistic. And notice that we have 7 dots that are at 8 or above. So the p-value would therefore be 7%. 7% means we would fail to reject the null hypothesis, and therefore there is not good evidence that the Rockets are a streaky team. So the nice thing about this section is that everything about it is the same as the other tests, except for the test statistic. That's the only part that's different. Let's look at one more example. Here we're going to look at these 9 seasons from the men's West Ottawa swim team. And you may remember from earlier in the chapter that when we ran this test, we came up with a p-value that was essentially 0, and we said that we had really strong evidence that they were a streaky team because they had a really long streak during these 9 seasons. So that was not a surprising result to us. However, if we're looking at the number of streaks, we want to see if we get the same result. So during this 9-season period of time, they had 83 meets altogether. Because 83 is between 50 and 100, we would need to look for 4 in a row to constitute a streak. So if we go back and look at the results, in 2012 and 13, they had a streak of 4 losses in a row. Then they had a bunch of wins in a row, and these wins would all constitute one streak, even though they kind of run from one season to the next. And then they had that loss against Rockford, and then all the rest of the games are wins, which means from the end of the 2013-14 season all the way through the end of 2021, those would all constitute one streak. So during this time period, they only had 3 streaks. So our hypotheses will be the same as they always are. The outcomes of the swim meets are independent, and our alternative is that they are a streaky team. Now notice the dot plot here. I have pretty limited number of possible values that could occur from the number of wins and losses that they got. So they could either have 3 streaks or 4 or 5 or 6. And our test statistic in this case was 3 because they had 3 streaks. Notice that all of the dots in this case are 3 or above. And that means that our p-value would be 100%. Now, 100% would lead us to fail to reject the null hypothesis. And in this case, we do not have good evidence that the men's swim team is a streaky team. So we're getting conflicting results from what we had earlier in the chapter. When we were looking at length of streak, we said that they were streaky, but based on the number of streaks, we would say they're not. That concludes lesson 3.4. Please do the 3.4 homework in your assignment packet.